My name is Gemma Fleming, and today I will be talking to you about error in science. The information in this presentation will help you when writing the discussion of your lab report. All experiments are subject to error in various forms, and it is an important component of working scientifically to discuss the known and potential sources of error in experiments. The aim of this presentation is to introduce you to the different types of errors, to familiarise you with some examples of errors, and to get you thinking about how you would reduce errors in your experiments. All experiments are subject to error, even ones that use the most advanced equipment and methods known to human beings. Errors affect collected measurements and results, causing them to vary from what actually happens in reality. Because error exists, we can almost never definitely prove the results of experiments, only conclude that they are supported or unsupported. In the cartoon pictured, even though it is fairly obvious that the bottle of poison fertilizer A does not produce plants as tall and healthy as fertilizer B, we can still only say that the results are supported, not that they definitely prove anything. The next important thing to note is that scientists actually know their research and experimentation has errors in it. Scientists can never prove with 100% certainty that they have described a phenomena with complete accuracy. Therefore, we must treat scientific results as having error. Your job as a student of science is to ensure that you minimize errors in your experiments as best as possible and be critical of other scientific claims and work. We know that all science has some error in it. Is there a lot of potential error and inaccuracy in a given experiment? Are the results reliable? Or is there an acceptable amount of error in a given experiment? Can we use the results with relative confidence? You will become more familiar with these skills as your journey into the world of science goes on. So, we have established that errors in science are virtually inevitable. Therefore, it is our job to try to minimize the effect of errors as best as possible. There are many ways to reduce error, and it is highly dependent upon the experiment at hand, the purpose of the experiment, the equipment, funds, and people available to undertake the research. For example, you will probably accumulate many errors in your bioscience lab report because you are only using simple equipment and may be working alone. If we had the funds, more highly technical equipment, and the interest in producing more accurate results, we probably could. But we must consider whether the time and money needed to make the experiment more accurate outweighs the purpose and the use of results. Can we justify spending thousands of dollars to determine what changes in pulse rate occur when we immerse our arms in cold and warm water? For the context of an introductory science course, probably not. The important point to take away from this information is to analyse your experiment and figure out what you can do to reduce the chances of error occurring. Can you measure more accurately? Do more trials? Use more accurate equipment? The list is pretty much endless. Error can be predictable or unpredictable. So how does it occur? It could be due to the fault of the experimenter, the fault of the equipment, due to a poorly designed experiment, due to miscalculations of results. At first it may seem as though there are countless sources of error and the identification of all of them near impossible. But with careful consideration of your experiment, and some practice, you will learn to avoid many sources of error and recognise the limitations of experiments because of unavoidable error. There are three main categories that we classify experimental errors into: human error, random error, and systematic error. Human error is due to mistakes made by the person conducting the experiment. Some examples include inaccurate measurement when we're not being careful or using the best technique, inaccurate setup of the equipment, calculation mistakes, and pretty much anything else that occurs due to the mistakes that we make when we're not concentrating. Random error. All experiments have random error. No experiment can be done with exact precision because of them. Random errors are unpredictable. Measurements may be slightly too large or too small. It is easiest to understand random errors using an example. For example, when you press a stopwatch, no matter how hard you concentrate to stop the button at the right time, it may be hit slightly too early or too late. Another example is when we weigh an object on a scale. If the scale is accurate enough, we are likely to get 3 similar but slightly different readings. We can never predict whether the readings will be slightly higher or lower than the true value. So what do we do about minimizing the effects of random error? We do multiple trials and take the average. Errors are random, so, in theory, they are equally as likely to be lower as they are higher of the true value. By doing lots of trials and taking the average, we can reduce the effects of random errors. Finally, systematic errors. Systematic errors are caused by something within your method that causes the data to be continuously skewed in the same way each time. This may sound confusing, and again, the best way to describe this type of error is with examples. For example, a systematic error may occur by consistently reading a ruler from the base with a little bit of extra plastic or wood, instead of at 0 millimeters. Results will be measured smaller than they should be by a few millimeters each time. Another example may be using a scale that is not correctly set up. It will consistently measure 0.05 or something along those lines heavier each time. Furthermore, another example may be a measuring tape which has been stretched over time. Every time it is used, items will be measured to be smaller than they actually are. Sometimes it is difficult to tell when systematic errors are occurring because all values are skewed in the same direction. There is no result that stands out as different. If possible, we may be able to do a reality check and think to ourselves, do the results seem realistic? Is this really what I expected? Unlike random errors, systematic errors cannot be eliminated by taking the average of multiple trials. This is because all results are either less or more than the true value. The bullseye on the targets represents the true value of results from an experiment. The blue dots on the targets represent where the results end up if affected by a systematic or random error. As you can see, systematic errors are all skewed to one side of the true value. Something has caused all of the values to be affected in a similar way. The random errors, however, are distributed randomly around the true value. If we took the average of the random error values, we would find they aligned somewhere close to the true value. It is important that you discuss errors that occurred, or potentially occurred, when you write about your experiment. This allows those reading to understand the limitations and scope of your results, and therefore what context the results can be used in. Scientists are rarely looked down upon if they realize the errors within their work and make them publicly known. Well, now that you've been introduced to errors, let's go through some questions to reinforce your understanding. You may like to pause the recording before I move on to the answer. A mouse is weighed on an electronic scale as 16.2 grams. We re-weigh it and the scale reads 15.9 grams. What type of error is occurring, and how could this error be controlled? If you'd like to pause, I'm going to read the answer now. A random error has occurred. To reduce the effect of the error, perform multiple trials and take the average value. Furthermore, calibrating, or making sure the scale works, would ensure measurements are as accurate as possible. Students in a health class are using a measuring tape to determine their heights. Matilda's height is recorded as 168 centimetres. However, she is certain that the measurement is incorrect because she has always measured 173 centimetres. Several other students seem to think their measurement is approximately 5 centimetres shorter than the last time they were measured. So, if all measurements read 5 centimetres less than in reality, what type of error is occurring? How might this error be amended? If you'd like to pause to think about the question, I'm going to move on to the answer. A systematic error has occurred. We can tell because all measurements are short by 5 centimetres. To see if the error exists, compare results with other tape measures. If the original tape measure is faulty, fix or replace it to amend the error. Sports science students are measuring sprint times. However, their stopwatch is running 1.5 seconds too fast. What type of error is occurring, and how can this error be controlled? If you'd like to pause, I'm now moving on to the answer. A systematic error has occurred. To amend the error, zero, calibrate, or use another stopwatch. If the students know how fast the stopwatch is running, they could simply subtract 1.5 seconds from each sprint time. Unfortunately, in reality, it's often very difficult to detect errors such as this. A researcher